All right, Algebra 1. We are in Section 4 today, but as you might notice, it is Part 1. That's right. Section 4, I am breaking up into 2 parts, okay? So this is actually for your benefit because the first half, much easier. Second half takes a pretty big step up. So for you to take in everything that Section 4 presents, I think it's really best that we break this one up into 2 parts, okay? The whole section is all about dividing polynomials, but it starts out a lot closer to what you've already done in the past in Chapter 8, when you were simplifying and dividing using exponents and variables and having to subtract the exponents, okay? So we're starting with a concept very close to that. So as you can see, remember everything that we learned when you guys were doing division with exponents, and don't forget that you can't keep negative exponents. You have to move those exponents, make them positive, and then you can deal with them by simplifying. Okay, so don't forget that. Again, this is only part 1. Next one we will be covering is part 2, and you have to pay extremely close attention. All right, here we go. Let's zoom in right here. If I'm highlighting an entire example problem, it's because I think it's important. All right, they break everything down for you in this example problem very nicely. All right, so the first term right here is what's going to go on top. That's why you'll see it here. Second term written is going to go on the bottom. You'll see it there. And you need to rewrite these always as a fraction. Okay, so this is just one unnecessary added step. Unfortunately, the book's going to throw at you that way. Okay, pay close attention to the fact that we could kind of separate this, right? -8 over 2, easily rewritten. That's what's going to give us the -4. And then the separate zone over here is simply a 5 minus a 2, and that's what's going to get us the 3. This you have done, all right? So it's that weird, unnecessary added step of just that division sign. Rewrite it, and then treat it just like you did last chapter, okay? So don't forget that. And this is one thing that was not in the last chapter. When you're dividing a polynomial, so let's imagine something much bigger than just one term, maybe 2, 3, 4, even 5 terms, and you're dividing that polynomial by a monomial, so in other words, one term, you have to take that monomial and you're going to need to write it under everything, all right? So that polynomial is going to be on top, then division, and the single monomial on the bottom. I'm going to show you how to take that, and you're going to write it under every individual term of the polynomial, and then simplify every single term all the way down the line. Okay, so let's do that. Actually, before we do that, here's a perfect example. All right, so here's your polynomial, here's your monomial, here's your, let's rewrite it in terms of a fraction. Then instead, let's take that monomial and put it underneath every single term in the polynomial. So now you'll see it. There's 3 terms, so I'm writing it 3 times. Then simplify every individual term, and that's what gets us down here. 4 divided by 2 is 2. 3 minus 1 is 2. 8 divided by 2 is 4. 2 minus 1 is 1. 10 divided by 2 is 5. 1 minus 1, that crosses itself out. That's why there is no x right there next to the 5. Okay? Also, it's in perfect descending order. 2, 1, and then nothing there. Okay? That's exactly how you have to do this. All right? So I've highlighted the whole thing. I would say I'd recommend at least copying down this part right here. It's not quite as important to get this part right in here. Okay, so this, real good example, copy that down. All right, let's do our example problems, and we will keep on moving. So first example problem, all I see here, it's a monomial divided by another monomial. You've done this already before. Let's rewrite this, negative 3d to the power of 7 over negative 9d to the power of 4. Okay, let's think of this as a little separation point right there. Negative 3 over negative 9. They're both negatives, so the answer is going to be a positive. 3 goes into itself, and it goes into 9, so there's a 1 over a 3. And if any of you ask, do I have to write the 1? No, you actually don't have to write the 1. But for those of you that like the visual, I'm putting it there. All right, next part is the 7 and the 4. 7 minus 4 is how we're getting d to the power of 3. And this is it right here. That is your solution. Okay, so basically it's d cubed divided by 3. That's really all you have to put for that problem. That was the first example. Let's take a look at the second example problem. All right, start again by rewriting this. First term goes on top. Second term goes on the bottom. All right, and I'm going to put a 1 there just so you can see that we will still use subtraction with those exponents. Don't forget that separation. Think of it like that. Kind of treat it like two little individual problems. 8 over a negative 6 can be reduced. It's still going to create a fraction. 2 is going to go into both of these guys, giving you a 4 over a negative 3. Don't forget about that negative sign. Still needs to be there. Okay. Now you have a 1 minus a 5. That's going to create a negative number, right? 1 minus 5 is actually negative 4. So here's the whole process that we go through. That's going to create x to the power of negative 4. Your answer is always written on top, but in this case, you cannot leave it on the top because it's a negative 4. So there's one added step to this problem. Let's walk backwards and do it again. 1 minus 5 gave me negative 4. And you always write that answer and put it in the numerator. But here's our added step, is because this has the negative 4, we're going to have to take that and move it down to the denominator, giving us 4 over negative 3 x now to the positive 4. All right, and I want some of you guys to hear this because some of you on the last test made this mistake. You brought that 4 down with it. That's not correct. You only bring down what that exponent is connected to. That exponent is just connected to the x value. That goes down there, okay? The negative 3 never moved. It stayed a negative 3. That 4 is not connected to that negative 4 exponent, so don't move it. That's why this is it right here for your final answer on number 2. Okay, let's do our last example problem. Okay, so what we are going to do is we're actually going to take this polynomial, and this monomial is going to be rewritten under all 3 of these terms. Okay, so let's do that. Then put the plus sign. That plus sign is that plus sign. Then a minus sign. There's the minus signs. Okay, so here we go. We have the entire polynomial separated out with the single monomial written underneath every term. Now we have to simplify all 3 terms, and let's do that. Okay, 6 over 3. That can simplify down to simply become 2. And then think of this as a 1 there. All right, you have 3 minus a 1, x squared. All right, so we took care of that. Then you have a 3 over a 3. They cross each other out. Then let's put that 1 there. 2 minus a 1 gives us just x right there. Okay, then we have a minus sign. 12 divided by 3 is 4. And you know what I just noticed? I forgot to write that x right there. Some of you may have already picked up on that. So that's very nice because these x's will cross each other out. Think of it as 1 minus 1 is 0. So all we had coming down from that one was the 4. And that, guys, is our solution for a polynomial being divided by a single monomial. All right, so that's all I got. Those 3 example problems cover part 1 of section 4. Part 2 of section 4, we're going to do tomorrow. All right, there we go. There's the entire example problem page. Take a good look. Everything worked out and broken down. All right. Come to class with questions if you got them. Make sure that you ask those questions. Don't let the moment pass you by. Make sure I get those problems done on the board so you can see how they're done correctly. And I'll see you guys in the next one.